Hi friends, welcome to learn Algorithm Design and Analysis course. In this session, we focus on matrix multiplication algorithms. We do like to focus on how to find the product of two matrices using conventional matrix multiplication method. Then we need to focus on how to find the product of two matrices using divide and conquer based matrix multiplication method. So, in this session, we focus on two things: how to find the product of two matrices with recursion and without recursion. First, let us explore how to find the product of two matrices without recursion, that is, by applying the conventional matrix multiplication method. Suppose capital A is a matrix of order m by n. Capital B is a matrix of order n by p, that is here m rows and n columns. For the second matrix, the order is n rows and p columns. Then we can find the product of the matrix defined by C is equal to A into B, such that the resultant matrix C has an order m by p. That means m rows and p columns. So, number of columns in the first matrix should be equal to the number of rows in the second matrix. Then only matrix multiplication is possible. For example, if A is equal to 1 0 0 1, B is equal to 1 2 3 4, then we can find the product of A and B using conventional method. Conventional matrix multiplication method. Since A is equal to 1 0 0 1 and B is equal to 1 2 3 4, clearly capital A is of order 2 by 2, B is of order 2 by 2. So we can find C is equal to A into B such that the resultant matrix also has an order 2 by 2. Now we can find C is equal to AB. This is matrix A is defined as 1 0 0 1, 1 0 0 1. Matrix B is defined as 1 2 3 4, 1 2 3 4. Now to apply the conventional method, we need to take first row, first column. This is first row, this is first column. Corresponding elements are multiplied and added. So it seems 1 into 1 1 plus 0 into 3 0. Then first row, second column, 1 into 2 2, 0 into 4 0. Then take second row, first column, 0 into 1 0 plus 3, second row, second column, 0 plus 4. So we have 1, then 2, here 3, this is 4. This is the product of two matrices A and B. Suppose A is a 3 by 3 matrix. A is a 3 by 3 matrix. A is equal to, say, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 3 by 3 matrix. A B is of an order, say, 3 by 2. 1, 1, 1, 3 by 2, 3 rows and 2 columns. 3 rows and 2 columns. Okay, 1, 1, 1, 1. So B is of order 3 by 2, 3 rows and 3 rows and 2 columns. Now we can find C is equal to A into B. So how do we find C is equal to A into B? Matrix A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Matrix B is 1, 1, 1, 1, 1, 1, 1, 1. Now we can find the resultant matrix by multiplying the first row and first column. First row, first column. Let's add the quantities, multiply and add the quantities. So it seems 1 plus 2 plus 3. Then first row and second column, we will get 1 plus 2 plus 3. Then second row, first column, 4 plus 5 plus 6. Second row, second column, 4 plus 5 plus 6. Third row, first column, 7 plus 8 plus 9. Third row, second column, 7 plus 8 plus 9. So this is equal to 6, 6, 15, 15, 24, 24. This is a resultant matrix C which has an order, this 3 by 2. Resultant matrix C takes an order 3 by 2. Here 3 rows, R1, R2, R3. Columns C1, C2. C takes this order a 3 by 2. Since A is 3 by 3 and B is 3 by 2, resultant matrix C takes a 3 by 2. In case A is 3 by 3, B is 3 by 3, square matrices A and B, right, of the same order. Then you can have the resultant matrix C is also of the same order, 3 by 3. Now let's have a look into how do we perform this arithmetic operations, multiplication and addition operations to bring the resultant matrix C is equal to, right, say C11, C12, etc., C21, C22, etc., right, likewise for the nth row. So to find out this thing, let's assume that capital A is a matrix of order m by n, capital B is a matrix of order n by p. Then we can find C is equal to A into B such that the resultant matrix C is of order m by p. So this can be achieved using conventional matrix multiplication algorithm, conventional matrix multiplication parameters are A array, B array, C array, then M, N, P. These are the external parameters. Conventional matrix multiplication, this is the name of the algorithm. Two matrices are externally supplied, A and B. The resultant matrix is C. C is equal to A into B. The operation is performed. Then the resultant matrix C is of order M by P. Matrix A takes an order M by N, B takes an order N by P. Now, this is performed using the for loops for I is equal to 1 to M do. Then the next for loop for J is equal to 1 to P do. Because M rows and P columns, resultant matrix should have M rows and P columns. So, controlling through two for loops, one controls the row, this controls the rows. Second for loop, this controls the columns. For I is equal to 1 to M do, for J is equal to 1 to P do. Initializing the entry Cij to 0, because each stage we need to consider the row and column. A row and column are corresponding elements are multiplied and added. So write Cij is equal to 0 to find the product and sum. Then how many elements are going to be considered in that row and column, that is defined using the variable k. For k is equal to 1 to n do, because this n that represents the number of columns in the first matrix as well as the number of rows in the second matrix. So, for k is equal to 1 to n do, here we are writing Cij is equal to Cij plus Aik star Bkj. So, this is the required computation, row wise and column wise, right, the corresponding elements, right, ith row and kth column. Here a kth row and jth column. Elements are multiplied and the elements are, right, corresponding elements are added, and the result gets updated in the variable C. Cij is equal to. Then we can close the for loops, right, outer for loops here, there, 1 and 2. So, 3 for loops imply to find the product A into B, such that the result is assigned in the variable C. C is equal to A into B. Then this opening curly brace, right, that should be closed here, closing curly brace. This is end of the algorithm. This is a conventional matrix multiplication algorithm. The row and column corresponding elements are multiplied and added. This is performed for M rows and P columns. Since the resultant matrix C is of order M by P, this is controlled through the outer for loops. I is equal to 1 to M for rows count and J is equal to 1 to P for columns count. Intermediate computation is controlled through this for loop. For k is equal to 1 to n do, simply Cij is equal to Cij plus Aik star Bkj. This finds the required computation. So, in this conventional matrix multiplication algorithm, passing the external parameters A, B, M, N, P, the resultant matrix is stored in the variable CRE, right, Cij, such that the dimension of C matrix is, right, M by P. C is equal to A into B, takes an order M by P. This is the conventional matrix multiplication. We can also solve the same problem, right, matrix multiplication, by applying the divide and conquer logic. So now we are going to see how to find the product of two matrices by applying the divide and conquer logic. Second method, method 1, that is the conventional matrix multiplication that we have seen here. This is method 1. Conventional matrix multiplication. In the second method, we are going to see how the divide and conquer logic is applied to find the product of two matrices. Method 2, divide and conquer based matrix multiplication. Suppose a capital A is a matrix of order which is written in a form of, right, say m by n, and capital B is represented by the matrix of order, say n by p, then we know the product C is equal to A into B is valid, such that the resultant matrix C is of order m by p. Now assuming that the matrices A and B's orders are represented in a power of 2. Suppose capital A is 2 by 2, capital B is 2 by 2. Or assuming that capital A order is 4 by 4, capital B is also of the same order 4 by 4. That means 4 into 4, 2 square into 2 square. Here the order is 2 square into 2 square. Or consider the next power, 2 power 3 into 2 power 3. Here also 2 power 3 into 2 power 3. That means 8 cross 8. Here also 8 cross 8. Or in general, assuming that capital A and B matrices take an order some 2 power n into 2 power n, B also takes the order 2 power n into 2 power n. In this case, we can apply the divide and conquer based algorithm, because when we have two matrices, say A is equal to A11, A12, A21, this is A21, A11, A12, then this is A21, A22, and B is equal to B11, B12, B21, B22, then we can find C is equal to A into B. That means C is equal to A11, A12, A21, A22, B11, B12, B21, B22. In this case, when the input size is 2 by 2. Matrix A is of order 2 by 2 and matrix B is also of order 2 by 2. Then we can find the resultant matrix C is of an order 2 by 2 in such a way that C is equal to A star B. Here we can write first row and first column. That means A11 B11 plus A12 B21. First row, first column, right? This is the resultant matrix C in which C11 is obtained. To obtain C12, first row is multiplied with second column A11 B12 plus A12 B22. Then second row, first column to obtain the element C21. That means A21 B11 plus A22 B21. Then second row, second column A21 B12 plus A21 B12 plus A22 B22. This is C22. So C11 is nothing but A11 into B11 first row and first column plus A12 into B21. C12 is first row or second column A11 B12 plus A12 B22. C21 second row first column A21 B11 plus A22 B21. C22 second row second column A21 B12 plus A22 B22. This way the resultant matrix C is obtained by applying the conventional logic. Now in the divide and conquer based method, assume that the input matrices A and B are of order 2 power n into 2 power n, same order 2 power n into 2 power n. In this case, we can easily split the matrix into smaller matrices or smaller problems. Once when the input size reaches 2, we can apply the conventional matrix multiplication method. Otherwise, we can split the matrix into smaller sub-problems recursively until the sub-problem size reaches to a smaller problem, where the smaller problem instances are defined like this, A and B. So when the input size reaches 2 by 2, the problem is to be a smaller problem. Otherwise, we need to split the problem into smaller sub-problems recursively. This is the logic of a divide and conquer based matrix multiplication. For example, consider two matrices A and B which are represented by 4 by 4 orders. Matrix A is of order 4 by 4, B is of order 4 by 4. We need to find a matrix C. C is equal to A into B. The resultant matrix C is also of same order 4 by 4. In this case, how do we apply the divide and conquer logic? Since C is equal to AB, just consider matrix A takes 4 by 4 element structure. I write just hyphen to indicate the elements. Matrix A. This is matrix B. For example, here the elements are represented like this. Third row, then a fourth row. Clearly matrix A is of 4 by 4 order. B is also of order 4 by 4. Now to apply the divide and conquer logic, since matrix A is 4 by 4, this should be split into 2 by 2 matrices, submatrices of order 2 by 2. So here we are splitting matrix A into 4 2 by 2 submatrices. This is matrix A. Likewise, matrix B is split into 4 submatrices, each of order 2 by 2 respectively. Now let's think this 2 by 2 matrix. This is say A11. This is a matrix A12. This is a matrix 2 by 2 matrix, not a single matrix, A21. This 2 by 2 matrix is simply A22. Then in matrix B, this 2 by 2 region is defined in B11. This matrix is defined as B12. This is defined as B21, and take this portion as B22, where each Aij and Bij defined in this matrix represents a matrix of order 2 by 2, not 1 by 1. Now consider A11, A12, A21, A22, B11, B12, B21, B22 as a 1 by 1 matrix. Then we can find the product using conventional matrix multiplication algorithm. So applying the logic here, just think of each element takes 1 by 1 matrix A11, A12, A21, A22. Then the second matrix B11, B12, B11, B12, B21, B22. Actually, each of Aij and Bij in this representation is a 2 by 2 matrix. Now just think of each Aij and Bij just like in this representation as a 1 by 1 matrix. That means each Aij and each Bij takes a single element. Then we can find the product using the conventional matrix multiplication. That means here this is first row and first column. A11 is multiplied with B11 plus A12 is multiplied with B21, so that we will get the resultant matrix C11. Then C12 is obtained as multiplying first row and second column A11 B12 plus A12 B22. Here we will get the second element C12. Second row, right, first column A21 B11 plus A22 B21. Second row, first column A21 B11 plus A22 B21. Second row, second column A21 B12 plus A22 B22. Second row, second column. So here this is C21, this is C22. This is valid when each Aij and Bij are taking a single element. Now actually each Aij and Bij are here a 2 by 2 matrices. This is a 2 by 2 matrix. This is a 2 by 2 matrix. Likewise B12 is a 2 by 2 matrix. B22 is a 2 by 2 matrix. Likewise these are also a 2 by 2 matrices. Now representing them in this equation, say C11 is equal to this equation, C12 is equal to this equation, C21 is this equation, C22 is represented by this equation. Clearly, what is C11? C11 is A11 into B11 plus A12 into B21. Now this A11 is a 2 by 2 matrix. Let's write separately. C11 is equal to A11 B11 plus A12 B21. A11, right, this is a 2 by 2 matrix. B11 is actually a 2 by 2 matrix. Here also A12 is a 2 by 2 matrix. B21 is a 2 by 2 matrix. That is represented here. What is A11, A12, B11, B21? Since this is a 2 by 2 matrix and this is one 2 by 2 matrix, A11 into B11, right? A11 into B11, two 2 by 2 matrices are multiplied such that it has this structure. For example, this is A11, this is B11. This takes a 2 by 2 order. This also takes a 2 by 2 order. Now each element in A11 and B11 is a singular element, 1 by 1 matrix. That stage we need to terminate a recursion. So to terminate a recursion, we need to call the conventional matrix multiplication method, right? So likewise, this part is computed plus this part also, right, computed as the product of a 2 by 2 matrices by applying the conventional matrix multiplication equations as we defined here. What is C11, what is C12 and C21 and C22. So using this method, we can terminate a recursion in case when the input size is in the form of 2 power n into 2 power n for both matrices, and assume the matrix multiplication is possible, then we can divide the matrices into smaller sub matrices which are of same equal sizes. Say 4 by 4 means the matrix is divided into 4 2 by 2 matrices in A and 4 2 by 2 matrices in B. How long we need to divide this into, right, equal submatrices of orders until the resultant matrix reaches a size of 2 by 2. When it reaches a size of 2 by 2, we can find the product using conventional matrix multiplication. Otherwise, this recursive logic is repeatedly applied. In case the matrices A and B are of order 2 power n into 2 power n, for example, matrix A is of order 2 by 2, matrix B is of an order 2 by 3, then C is equal to A star B is possible. Resultant matrix takes an order 2 by 3 or 2 rows and 3 columns. This case, how do we apply the divide and conquer logic? We need to convert the matrix A from 2 by 2 into the equivalent or nearest matrix which takes the power of 2 power n into 2 power n, such that both matrices A and B should be converted to the same order 2 power n into 2 power n. Since it takes 2 rows and 2 columns, we need to add 2 more rows and columns, 2 more columns with dummy entries like this 0, 0, 0, 0. So that matrix A is converted to order 4 by 4. And likewise matrix B currently takes 2 rows, 3 columns, 1, 2, 2 rows, 3 columns, right? 2 rows, row 1, row 2, C1, C2, C3. 2 rows, 3 columns. This should be converted into same 4 by 4 matrix by introducing the enough dummy rows and dummy columns. For example, here 0, 0, 0, 0, 0, 0, 0, 0, here 0, here 0. Now we have converted both matrices A and B into the nearest power of order 2 power n into 2 power n, same order 4 by 4, here also 4 by 4. Now if we write C is equal to A into B, clearly A takes order 4 by 4 and B takes the same order 4 by 4. As we have done earlier, we can split each matrix into 4 sub-matrices of equal order, say 2 by 2 order. Then we can fix what is A11, A12, A21, A22, B11, B12, B21, B22 as we defined earlier like this. So define each Aij and Bij as a 2 by 2 matrix. Then just consider each matrix as a singular matrix, right? Each matrix as the matrix with only one element, one row, one column, 1 by 1 matrix. Then you can find the product, right, using conventional matrix multiplication. Then since each matrix is actually of order 2 by 2, not a matrix with order 1 by 1. So next stage, again you need to apply the conventional matrix multiplication to find the product of 2 by 2 matrices. Then you can find each Cij as a 2 by 2 matrix, so that C is equal to, right, we will get this is a 2 by 2 matrix, here this is a 2 by 2 matrix, C21 is a 2 by 2 matrix, C22 is a 2 by 2 matrix, so that you will get the matrix of order 4 by 4. Since A and B are of order 4 by 4, resultant matrix should take the same order 4 by 4. This is a logic of a divide and conquer based matrix multiplication, when the matrix multiplication is possible and when the order is not in a form of 2 power n into 2 power n for both matrices A and B. So convert the matrix into the next nearest power of 2 as 2 power n into 2 power n by introducing enough number of சரி, வாய்ஸ் வருதான்னு அப்படியே செக் பண்ணிக்கங்க போய். So matrix A is of order 2 by 2 and matrix B is of order 2 by 3. Then matrix multiplication C is equal to A star B is possible. The matrix C takes an order 2 by 3. In this case, to find out the product of A and B, what we have to do, since A and B are not in this order 2 power n into 2 power n, so we need to convert the order into the nearest power of same order 2 power n into 2 power n. So matrix A, which is represented like this, A is equal to 2 by 2, this should be converted into the 4 by 4 order. Introduce enough number of dummy rows and dummy columns so that we will get this resultant order 4 by 4, or 2 rows, 2 dummy rows and 2 dummy columns, so that 2 by 2 is converted to 4 by 4. Likewise, matrix B is of order 2 by 3 and matrix multiplication is possible. So 2 by 3, this should be converted into the nearest power of 2, right? So here 3 means, right, this should be converted to 4. 2 by 3, this is converted to 4 by 4. So introduce enough number of dummy rows and dummy columns so that the resultant matrix is of order 4 by 4. Now writing C is equal to AB, what happens? A C is represented in this form, A and this is B. Consider each Aij as a 2 by 2 matrix. Now if we take each Aij as a matrix which consists of 1 by 1 order, then we can write Cij as this representation. Cij is equal to A11 A12 A21 A22 into B11 B12 B21 B22 with this equations. So C11 is represented by this equation, C12 is this one, C21 is this one, C22 is this one. When we assume each Aij and Bij as a matrix of order 1 by 1, but after writing this, it seems that actually each Aij and Bij is not a 2 by 2, sorry, not a 1 by 1 matrix, but actually it is a 2 by 2 matrix. Each Aij and Bij is a 2 by 2 matrix. So just write, put values of A11, B11, A12, B21 here, then find the product of a 2 by 2 matrices, right, using conventional matrix multiplication algorithm. That's what here, have a look into C11. C11 is, right, A11 into B11 plus A12 into B22. Each Aij is not a matrix of order 1 by 1. Likewise, each Bij is not a matrix of order 1 by 1. Instead, each Aij and Bij is a matrix of order 2 by 2. Here also 2 by 2. Now to find the product of these two matrices, right, 2 by 2 orders, we can apply the conventional matrix multiplication so that here the resultant matrix is of order 2 by 2. That is this one. This is C11. So in this representation, C11 here is actually a 2 by 2 matrix, not a 1 by 1 matrix. Likewise, C22, C12, C21 all are 2 by 2 matrices. So that the resultant matrix C takes an order 4 by 4. Since A and B are matrices of order 4 by 4, resultant matrix C is of order 4 by 4. Here we have converted A into 4 by 4, B into 4 by 4. Then we have obtained C as 4 by 4. C, resultant matrix C is equal to AB, which is of order 4 by 4. But actually in the resultant matrix C is equal to AB, we need to take only this portion or 2 rows and 3 columns. So after obtaining C is equal to AB as a 4 by 4 matrix, we need to consider only 2 rows and 3 columns, or 2 rows and 3 columns. Remaining elements, right, these are ignored. Remaining elements will be as zeros. Only this portion, right, as 2 by 3, 2 rows and 3 columns, that is the actual 2 rows and 3 columns. That is the actual product of two matrices A and B with the orders 2 by 2 and 2 by 3. This is the logic of a divide and conquer based matrix multiplication algorithm. Divide and conquer based matrix multiplication algorithm. In case if the input size is already in a form of 2 power n into 2 power n common orders, no problem, we can subdivide the matrices into, right, n by 2 into n by 2. Since this is 2 power n into 2 power n, suppose if this is capital N into capital N, capital N into capital N, then A is subdivided by 2, n by 2, n by 2, right? Then B is also subdivided by 2, right? N by 2 into n by 2. Then check n by 2, right? If it reaches a quantity 2. If not, n by 2 is further subdivided by 2 to have n by 4 by n by 4. B is also subdivided by 2 further, n by 4 into n by 4. So this is continued until the last submatrix that results in order 2 by 2. So once you reach the subproblem size is 2 by 2, we can directly find the solution by applying the conventional matrix multiplication method. This is the logic of a divide and conquer based matrix multiplication. Now let's see one example to illustrate the divide and conquer based matrix multiplication. Example, if A is equal to 1, 2, 3, 4, 4, 3, 2, 1, 5, 6, 7, 8, 8, 7, 6, 5, and a matrix B which is of order 4 by 4, say 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Then find AB using divide and conquer based matrix multiplication. Solution: first write C is equal to A into B. What is A? A is represented like this: 1, 2, 3, 4, 4, 3, 2, 1, 5, 6, 7, 8, 8, 7, 6, 5. A is of order 4 by 4. Matrix B is also defined as a 4 by 4 matrix. 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. This is also a 4 by 4 matrix. Now to apply the divide and conquer logic, these two matrices are first subdivided by 2. Subdividing each matrix by 2, here we will have 4 submatrices which are of equal size, or 2 by 2. So consider each matrix. This is A11, this is A12, this is A21, this is A22, this is matrix B's, B11, B12, B21, B22. Now actually we have the order in the resultant matrix C, right? That is C11, C12, C21, C22, where each Cij is a matrix of order 2 by 2. So how to find a C11? A C11, this is obtained using normal matrix multiplication. If this is A11, A12, A21, A22, then B11, B12, B21, B22, then C is obtained as the product of first row and first column, A11, B11 plus A12, B21. So finding the product of A11 and B11, it seems 1, 2, 4, 3, 1, 2, 4, 3. This is multiplied with B11. B11 is 1001 plus A12. A12 is 3421, 3421. B21 is all zeros, 0, 0, 0, 0. So simplifying this is C11. We will get 1 into 1, 1 plus 0, then first row, first column, then first row, second column, 0 plus 2, first row, first column, 4 plus 0, then 0 plus 3, plus remaining elements are here zeros. Simplifying here, this is 1, 2, 4, 3 plus 0, 0, 0, 0. We will get 1, 2, 4, 3. This is C11, where C11 is a 2 by 2 matrix. Likewise, a C12 is obtained using conventional matrix multiplication. C21 and C22 are also obtained by applying the conventional matrix multiplication. So that we will get the same, right? C11, right? Then C21, C21, this is 3421. We can easily verify, since we are multiplying this matrix with matrix which consists of zeros and ones. Here we will get C is equal to AB as the same matrix A. Then C C11, this is C12, then C21, C21 is 5637, 5637, C22 is 7865, 7865. We can apply the same conventional matrix multiplication similar to, right, C11. We can find C12, C21, C22 and find the product of two 2 by 2 matrices applying conventional matrix multiplication and finding the addition. We will get this result. Finally, the resultant matrix C is obtained by substituting 4 2 by 2 matrices in this equation. So, updating the matrix C here, we will get C is equal to C11, C12, C21, C22, where each Cij is a 2 by 2 matrix. 1, 2, 4, 3, 1, 2, 4, 3, that is C11 is replaced here. Then replace a value of C12. C12 is 3, 4, 2, 1, 3, 4, 2, 1. This is C12. Then C21. C21 is 5, 6, 3, 7, 5, 6, 3, 7, 5, 6, 3, 7, okay. Then C22. C22 is 7, 8, 6, 5. C22 is 7, 8, 6, 5. Now this is the resultant matrix C, which takes an order 4 by 4. So applying the divide and conquer logic, finally we have obtained the resultant matrix C, which takes an order 4 by 4. In case if we apply the conventional matrix multiplication as we defined earlier by taking here first row and first column, finding the product of first row and first column, right, elements here, 3 elements are 0, it seems, you will get 1. Then first row and second column, right, you will get 2. First row and third column 3, first row and fourth column 4. Likewise, for second row is multiplied with here second row, right, first column, second row, second column, second row, third column, second row, fourth column, we will get this order 4, 3, 2, 1. Likewise, the third row in the resultant matrix is 5, 6, 7, 8 and the last row in the resultant matrix is this one 8, 7, 6, 5. This is 8, not 3, 8, 7, 6, 5. This is 8, 8, 7, 6, 5. So this is the product of two matrices which are obtained by applying the divide and conquer logic. So in this session, we have focused on how to find the product of two matrices by applying the conventional matrix multiplication as well as divide and conquer based method.